Hello, this is Keith from Kinvert, and we're going to be going over another example of y equals mx plus b, and this is a real-life example. So at Kinvert we teach 3D printing, and one of the things you need to do is there is a nozzle that you put the metal into, and it will melt. Why did I say metal? You'll put the plastic in it, and the plastic's going to be going into here, heating up and melting out. Alright? And one of the things you need to do is heat this nozzle. Alright, it's called preheating in 3D printing. And I wanted to see how long it's going to take. So I put a stopwatch and I timed this. And when I started, when the clock was at 0 seconds, the temperature was at 18 degrees Celsius. And I was aiming for 245 degrees. Now, it only tells you every once in a while what the temperature is. So that was at 246 degree. I'm getting that backwards. Let me erase that. Go back. And it was at 81 seconds. And we were at 246 degrees Celsius. And one of the things I want to do is see, is the temperature growing in a linear fashion, or is it maybe growing quickly at first and then slowly climbing? Okay, so what we're going to do is make a slope-intercept form. Y equals mx plus b. We're going to create that equation based on this data, and then I've also got the information for 40 seconds. What is the temperature there in degrees Celsius? So let's start setting this up. I want you to think for a second. Here's your data. First, try to think of which is the x-axis and which is the y-axis. Okay, so you're going to have x and y here. Which is it going to be? Seconds on the x-axis? Is it going to be the temperature, degrees Celsius on the x-axis? Think about that. Pause it. You can hit the K key, by the way, to pause. So 3, 2, 1. All right, here's the answer. We are going to put on the x-axis is going to be time. So that is in seconds. And on the y-axis will be temperature, and that is going to be in degrees Celsius. All right? And then I want you to think about, how is this graph going to look? Now, you don't have to predict perfectly if it's going to do that, or here's, another possibility or something. But is it going to be the way that we chose these axes? Is it going to be downward slope, upward slope? The intercept, is the intercept going to be like this or like this? Where's the intercept itself going to hit? Okay, so take a minute to think about that. And you're going to actually have some more time. So try to now, try to start actually solving and finding what is the form of this equation going to be. What is the coefficient m going to be, and what is the constant b going to be. All right, so try to think about that. And I'm about to start setting up these equations. So please pause the video, hit the K button. 3, 2, 1. Let's start solving this one, all right? So I'm going to go for yellow, I guess. So we're going to have two equations, and again, they're y equals mx plus b. So y is 18 for this first one, equals m, which is unknown, times x, which is 0, plus b. Well, I can already know that. I already know that b equals 18 because m is canceling out here, right? So b is 18, so that's nice. For the second equation, the y is 246 equals m times x, which is 81, plus b. And so now we can solve this one more directly. We're going to have, we got to get the 18 away from both sides. So we have 228 equals m times 81. So now we divide both sides by 81, and m will equal, let me quick do this, 228 divided by 81, and 2.81. m is 2.81. So now let's think about what the units would be here. So that would be, what, rise over run, so degrees Celsius per second is going to be the slope of this. That's good news. I got to do this quick. So now let's start mapping this out. We're going to put 18 here. We're going to put 0 seconds there. We're going to put the 81 seconds here. And for the time, or for the temperature, we'll put the 246 degrees Celsius here. Okay, so now at 40 seconds, what was the temperature? It was, oh my gosh, am I blind? Where'd I put it? Uno momento. It was 132. 132. Now let's calculate it with our equation. So we have y equals mx plus b. And let's calculate this at 40 seconds. 2.81 times 40 plus 18 gets us 130.4 degrees. And that's not bad. That's not bad at all. I am surprised at how well. So that might fit linearly. So what I'll do in the future is make another video where we actually measure out more of this data. But anyway, I got to stop recording before my battery dies. I'll lose the video. This is Keith from Kinvert, and I hope this was helpful. See ya. Bye.